Couple of things. Normal force. We talked about, what is it? Someone explain to me the normal force.
The force of the ground pusher, the force of an object pushing back perpendicular to another object.
Okay, perpendicular to the surface. So, okay, here's a couple of examples for normal force. Let's talk about normal force. Okay, if I have a normal force, huh?
What?
Yeah, it's the machine gun. All right, so here we go. Normal force. If I have a ground, I have some sort of ground, right? I've got an object, okay? The object is sitting on the ground. All right, the object has what kind of force associated with it? Force of what? Gravity. And that force of gravity is also called, it's what? We use it a lot normally. You stand on a scale, you have your weight. So remember, your weight, if you have a weight, that's the force due to gravity. Okay? So you can determine your mass, right? If you weigh 100 newtons, okay, equals my mass times my acceleration. What's the acceleration due to? Well, gravity. Do we know that acceleration rate? Yes, it's 100 newtons is negative, because that's your weight downward, equals mass times negative 10 meters per second squared. You guys see that? So what's your mass? What's your mass, boys and girls? So if your weight is 100 newtons, let's take pounds, right? You can convert pounds to newtons. Okay? You know the acceleration rate because your weight's due to gravity, right? What's the acceleration rate due to gravity? Because it's down. Because if it's negative 10, it's got to be down. Your weight goes down. You're the force of gravity. What direction does the gravity pull you? Down. So therefore, it should be negative. The negative and positive is all about direction. So if I solve for mass equals negative 100 newtons divided by negative 10 meters per second squared. Because can you have a negative mass? No, you have to always have a positive mass. Yes, ma'am. You with me?
Oh, yeah.
Oh, you have a question?
No, I got you.
Okay. So that means I have what's my mass? 10 what? No. Yes, kilograms. So it's 10 kilograms. Force equals mass times acceleration. Force is in what units? Newtons. What's your mass in? Kilograms. What's your acceleration rate? Meters per second squared. Okay. This is important, guys. You need to know this. You need to know this. This example right here is a perfect test example. Wink, wink, nudge, nudge. Right? Perfect example to ask you, something I could ask you on the test. Yeah. Okay. Maybe I ask you on a different planet with a different gravity weight, different acceleration rate due to gravity. Everyone with me? Drew, I see an inquisitive look. You're good? Okay. All right. So if I've got a force due to gravity, okay, what kind of force do I have from the ground?
Positive force.
Yeah, but what kind of force? What do we call it? Normal force. Okay. So I've got if I've got my weight from the object, okay, F of G, I have a normal force Fn pushing back perpendicular to the floor. Okay? If my weight is Fg and the ball or object is not moving vertically, what is my Fn?
Well, your net is the same as the gravity.
Yeah, the absolute value is the same, but opposite direction, right? So Fg must equal Fn, so that Fg plus Fn equals what? 0 newtons. Does that make sense? Normal force is the force pushing perpendicular. Okay? Here's another example. Let's say I have a vertical wall. Let's say I have my hand. I'm going to draw a really horrible looking hand. Okay? And I'm pushing with a force of hand against the wall. Where's my normal force? Do I have a normal force?
Yes. The wall.
Which direction does it push? Okay. So my normal force is perpendicular to the wall. You guys see that? And that normal force, if I'm pushing against the wall and the wall isn't moving, what do I know about the values of the forces? So F hand equals Fn. So that the sum of the forces Fh of the hand plus, my Fn will equal what? 0. Because Fh is in what direction? Positive or negative? In this orientation, positive. What's Fn? Negative. You guys see that? Because, again, we go back to this scenario where we have upward y positive, to the right positive x. Everyone with me? Okay. So this is about our normal force. Now, trick question. Let's say I have, a ramp, okay? And let's say I have a ball again, and the ball's going to roll down. It's going to start to roll. Do I have a normal force?
Yes.
Why? How do you know I have a normal force?
Because you still have an object resting on it.
Yeah, the object is not going through the floor, right? I mean, what direction does gravity? What direction is my gravity force in this example? What direction is my gravity force in this example? Okay, for all of you guys who are doing this, meaning it's all you guys who are saying my force of gravity is this direction, let's think about this logically. I know why you do it. The what? Gravity only pulls in what direction? Up and down. This is my force due to gravity. That's my net force, okay? Because there's another force pushing back. And we won't get into this problem because it's a fairly complex. If you want to, we can. But I want you to understand this basic concept. On this concept, this is what I want you to understand. My gravity force is still pushing down, right? Where is my normal force pushing? Perpendicular to what?
The way the ball touches the ground.
Okay, so this is my normal force. Does everyone see that? Okay, and that angle ends up being this angle. Okay? So my gravity force is always pushing down, and my normal force is always pushing perpendicular. Okay? For this class, all I want you to be able to do is do this drawing. I want you to be able to understand this, understand where normal force is. I'm going to change that drawing up a little bit, so just to make sure you understand. But the idea is that the normal force is always perpendicular to the surface which is pushing back on the ball or on the object. Okay? Does that make sense? Any questions on that? Don't just memorize this image and try to regurgitate it. You will not answer my question appropriately. Understand what's happening. Okay. All right. Let's do some work. Let's do some actual stuff here. Okay. Let me make sure I don't get it. All right. Let's do this. Okay. Let's set up a basic example. Okay. And I'm going to have my crate sitting on the ground. Okay. Right? And all right, let's say I'm going to have a couple things going on here. Let's start with a simple one. Let's start with, rather than making it too complex at the moment. Let's do this. We're going to have a force of tension from the rope, okay? And we're going to have, and let's say that this crate has a mass. The mass of the crate is 100 kilograms, okay? What I'd like you to do is I'd like you to tell me two things. Let's assume that the force of tension is equal to 120 newtons. Okay, 120 newtons. Okay. What I'd like you to tell me is two things. Number one, is there enough force to lift the crate off the ground? So is the crate on the ground or not? And then what is its motion? And that's direction, type, and amount. Type meaning, am I constant velocity, am I constant acceleration? And if it's one of those two, what's the acceleration rate, what's the velocity rate? Does that make sense? All right, so work that out together. Let's start working this out. I know this may be something that you may not know exactly how to start, but I want you to think about it. You need one more piece of information. You need this to be 30 degrees. Okay? All right, so let's go ahead and do that. Start to talk with each other about how to start that. You should have all the pieces in your toolbox. This is probably the first time you're putting them together. So think about what you have to do. Just talk about what you've got. Shh. Okay, guys, look up here for a second. Look up here, guys. Everyone look up here. Okay, really fast. If I've got a triangle, okay, here's my triangle. If I know my hypotenuse, can I figure out my x length and my y length? And I know my theta. If I know my theta and my hypotenuse, can I figure out those lengths, right? Okay. If this hypotenuse was 30 meters per second, what does that mean? What does that mean about the x and the y? It's a velocity. What kind of thing is x and y? What's going on here? Explain to me what's happening. If I'm traveling, huh?
It's split between the force is split between them.
Well, in this case, I'm talking about velocity, right? Right. Let's say I was 30 meters. Okay. Let's say I'm 30 meters. In order to go 30 meters at that angle, I have to go a certain number of meters this direction, a certain number of meters that direction to get there. If I was going to go purely horizontal and vertical, right? I can go from point A to point C directly. Or I can go from point A to point B and then point B to point C, right? Everyone? Yes, yes? Okay. Okay. So how would I figure out the distance for x? Let's say the angle was 20 degrees. How would I figure out the amount of x? Guys. Okay, the sine of 20 degrees equals y over 30 meters. That means y equals 30 meters times the sine of 20 degrees, right? Everyone see that? And how do I figure out the x version?
Cosine of 30 or cosine of 20 is x over 30.
Okay, so x equals 30 meters times the cosine of 20. Okay, let me ask you a question. What if this is 30 meters a second? Does it change anything mathematically? No. That means that if I'm going 30 meters a second at an angle of 20 degrees, that means that part of my velocity is horizontal and part of my velocity is vertical. Everyone still look up here. I want everyone looking up here, because this is something that you guys aren't getting, so I want to make sure you're here. If I'm going 30 meters a second at that direction, that means a part of that amount of velocity, that part of that 30 meters a second is horizontal. Part of it is vertical. Okay? If it's a force, if it's 30 newtons, then part of that force is horizontal, part of it's vertical. They're all vectors. It's all the same thing. And I feel like we're talking about this, and I feel like you guys are like, I have no idea. We've never done this before. I'm going, yeah, we have, right? You guys remember the distance and the vector stuff, right? This is the same concept. Same concept. Everyone with me? All right, I just wanted to get that down. Continue on. Figure it out. Go, 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 go. So when we go through this, the purpose of doing this is not to annoy you, even though you think that's what it is. I'm trying to get you to struggle through this. It can be a little frustrating, but you've got to think about this. You can't just sort of sit back and be like, oh, I'm going to wait till Mr. A goes over. That's fine. The problem, though, guys, is that if you're not struggling with this, you're not gonna really understand it. You've really got to struggle through this and learn this on your own and figure this out. You're not gonna get everything. I don't get it. I get that. But you need to not give up. You need to talk to people and start to have that conversation. Keep moving. Just sitting back, not knowing and not doing anything isn't gonna help. Okay? I feel like I have a few people who are really pushing that, and I don't feel like everyone's doing that. And again, the problem is you're not going to get there if you don't struggle through this. All right, so let's talk about this for a second, right? Let's start with the free body diagram. I'm going to start with the free body diagram, okay? Let's start with the free body diagram. You should, and I know I did this, I know I asked you to do the free body diagram at the end, and that was purposeful, but normally you want to start with the free body diagram at the beginning. So what are the forces that are acting on this box? Give me the first big one. Gravity. Okay? This is F of G. Okay? What's the next big one that I have acting on it? The ground. You can do the ground. We're going to call, if we're sitting on the ground, that means there's a force pushing back up on it, and that's called the what force? Normal force. Okay? Then the last force I have is what? The tension force. Okay? The problem is this. I can take FG and Fn and I can do what with them? Mathematically. Or I can add them up, right? And get a total sum, right? I can sum the forces in the y direction, right? The problem, and I can sum forces in the, right now, do I see any immediate forces in the x direction? No, I don't see any immediate ones, but it doesn't necessarily mean I don't have any. But if I had a force in the x direction, could I add it to the force in the y direction? No, they're completely independent. What's the problem with f of t?
It's divided between x and y.
Right, it's not vertical or horizontal, it's divided between the two. There's a portion of it each. So I could break this down, and I could re-explain my free body diagram with replacing this f of t with two other forces. Okay? I could replace it with a force Fty and Ftx. Now, I don't expect you to do this right now, but I want you to give it a shot. Now, let me ask you a question. If I have Ft and I've broken it down, this is an important part, guys. If I have Ft and I've broken it down to Fty and Ftx, what's the problem with how I've got it drawn right now? What's the problem with that? I have Ft here, and then I broke it down. I've also put on the free body diagram Fty and Ftx. Hmm? What do you mean? Be more clear.
Well, I mean, instead of having the total of FT, you have FTY and FTX, and you have to split FT.
Right, and so you're, and let me, what were you?
You can't have both of them.
Is that what you mean? You can't have both? Right. You can't have both. If I've split Ft into its component vectors, I can't leave Ft up there. I've got to get rid of it, right? Otherwise, you have two Ft's. Does everyone see that? This is a really critical part, because when I ask you to do this on an exam, you're going to need to be able to make sure that you don't do this. This is incorrect.
So which one would you want?
Which one can you work with? Fty and Ftx. So get rid of that. Okay? Because now I can deal with my Fty relative to my Ftn and Fg, and I can deal with Ftx on its own. Does that make sense? Okay. So notice, guys, I haven't plugged any numbers into anything just yet. Okay? Let's sum the f of x and the f of y. Let's sum them up. What's my fy? What's the sum of the forces in the y? What are they? Fg plus Fn plus FTY. It's really simple. Don't overthink this. This is so simple, anyone can do this. You just have to not overthink it. Your objective is to get everything in the x and the y and sum them up. Simple as that. Okay? And then you're going to determine at the end, when you sum them, what do you have left? Okay? What about my fx, the forces in the x direction? What about the forces in the x direction? I have ftx. Do I have anything else? That's it. Right? Okay? And all of these equal, this summation is going to equal what? What's it going to ultimately equal? An equation variable form. That maybe this summation, I have some force and force and force. What am I going to end up with? A what? A net force, right? I'm going to end up with some sort of net force in the y. I'm going to end up with some net force in the x. And that net force can be broken down from an equation standpoint to equal what? Basic F equals what? F equals what, guys? Mass times acceleration. So it's my mass times my acceleration in the y. And this is going to equal my mass, the same mass of the crate, times the acceleration in the x. Does that make sense? Okay. So now the question is, now that I have that, all I really want to do is I want to solve for some values, okay? I'm going to take, I'm going to take this guy here, and I'm going to move it to a different layer because I want to deal with, I want to put it on a different layer so we can deal with that separately, okay? All right. So let's deal with this portion. I'll come back to that in a second. Let's deal with this portion. At the end of the day here, right? I have my FT. I can do my triangle, right? And let's get rid of this. All right. What do I have here? If I've got, how would I use if I have my FT, what's on the vertical leg here? What do I call that? FTY. What's the horizontal? FTX, right? And what was my angle? 30 degrees. Okay? So now, how do I determine an FT is equal to what? 120 newtons, right? Is that correct? All right. So how do I determine the amount of force in the x and the amount of force in the y? How do I do that? SOHCAHTOA, right? So let's do the y. Sine of what? 30 degrees equals FTY over 120 newtons, right? So FTY equals 120 newtons times the sine of 30 degrees, right? So what is that? Sine of 30 is?
No,
It's 1/2, isn't it?
it's one of the
Sine of 30 is 1/2, right? So it's going to be a half of 120. So FTY is equal to 60 newtons, right?
Wait, you want us in radians then?
Hmm.
You want us in radians then? If the sine of 30 degrees isn't still 1/2.
Yeah.
It is.
30.
I thought that was the radian. Oh, so you guys. I thought it was only radians. My bad.
Yep. Okay. So FT. Now, how do I figure out FTX? Well, the cosine of 30 degrees equals FTX over 120, right? So now it's FTX equals 120 Newton times the cosine of 30 degrees, right? So 30 cosine times 120, 30 cosine times 120 is 103, okay? Okay? So the question is, here's the question. Hold on, guys, hold on. Give me 2 more minutes. Here's the question. Okay, if my box has, so the sum of, so let's go back to here. So the sum of the forces in the y, what's my FG rate? What's my FG? Okay, the force is not force is what? The force of G is what? Force of gravity. Fg equals negative 10 meters per second squared times my mass, 100 kilograms. So that's going to equal 1,000 newtons, right? Negative, right? So it's negative 1,000 newtons plus Fn plus, what's my FTY? 60 newtons. Is up or down? Up, okay. That's going to equal my total net force in the y direction. Here's the question. Do I have more force down or more force up? Down. So what's going to happen? So I have to figure out what Fn is. We have to assume that my acceleration is what? Vertically, 0. So Fn is going to equal to 100 or 1,000 newtons minus 60 newtons. Okay? All right, we'll finish this tomorrow.